Good morning. We're going to talk today about 4.1, which is matrices, starting Unit 4. A matrix is a rectangular arrangement of numbers in rows and columns. And so, the numbers in a matrix are called elements. Each of these then, this, if you see, those are each elements of the matrix. The number of rows, which are horizontal, so if we, whoops, that's not what I wanted to do. Oh, great. Okay, let's get that back on here. It's supposed to be. Okay. All right, the number of rows and the number of columns. So when we talk about matrices, then we look at, these are rows, each of these, so there's 3 rows, and then the columns go this way up and down, and so we define a matrix as the dimensions are always written rows first and then by columns. I always tell students I think of R.C. Cola, which many of you may not even know what that is, but that's how I think of what size the matrix is. So this one, if we're looking at dimensions, this has 3 rows here, and it has 2 columns. Okay, these are rows, and these are your columns. So the dimensions of this matrix are 3 by 2. Okay. This has 2 rows. Again, rows go this way. So it's 2 by, and it has 3 columns. So remember, row by column when you're thinking dimensions. And this one is what we call a square matrix. It's 2 by 2. And there are going to be some things later that you can only do with square matrices. 2 matrices are equal if they have the same dimensions. So in other words, this is a 2 by 2 matrix, and so is this one. So they are equal and have the same elements in corresponding positions. And so the equal sign here tells me that those are equal matrices. Then I can draw some conclusions from knowing that they're equal matrices. If I know they're equal matrices, then I can figure out that corresponding elements are the same. So in other words, this element will be the same as this element. So if I need to find the value of a variable, in this case, then x equals -9. Now let's find another corresponding element. Let's change the color of my highlighter a little bit. Okay. And so y here is the same as that. So y then is equal to -2. And 3 equals 3. I can see that. That's not a variable. But if I look at that element, I can see that it also corresponds. 3 here equals 3 here. And then the last variable that I need to worry about is the z variable. And so in this particular case, z is equal to excuse me, -6. Excuse me. So then I've got this other matrix here that I want to, that are equal matrices, and I need to figure out the variable. So again, we see 5 equals 5. 5 equals 5. If I go back, I can tell they're equivalent. 3 equals 3. But then I have these variables. I have x plus 9. What does that equal? Well, remember, they're in the same spot. So, if I go back, then x plus 9 must equal 7. So then I can figure out what x is. If x plus 9 equals 7, then x must equal negative 2. Okay? Now looking at our last situation down here that we haven't highlighted, and you're going to have to look at it and figure out the way that it most makes sense to solve it. Here, 2x minus y equals 1. So, if 2x minus y equals 1, well, that's all fine and good, but that I have two variables. But we figured out here what x is, so instead of that, this x, I can substitute in my negative 2, okay, because I know that x is negative 2. So now we have, let's see if I can make this a little bigger and find a spot to put it. We have negative 4 minus y equals 1. Okay, and so negative y is equal to 1 plus 4 or 5, so y must equal negative 5. So now I've figured out that what y is and what x is using these equivalent matrices. So when you're given equivalent matrices, you should be able to solve for the variables. The other thing we're going to do in this lesson is find the sum, or one other thing we're going to do. There's two more things. If two matrices have the same dimensions, so this is a key statement right here, they have to have the same dimensions. Well, okay, there we go. If they have to have the same dimensions, then you can add, and you just add corresponding elements. So if I want to add a plus b here, it's very simple. Matrix A, you put that in, and it's 1, 3, negative 2, 4, 0, negative 5. And I want to add that to matrix B, which is 3, 1, negative 5, 0, negative 7, 2. And so the answer matrix, you just add the corresponding elements. 1 plus 3 is 4. That's adding these two right here. The middle element's going to be, I'm not going to highlight everything, but I'll highlight a couple of them. 3 plus 1, and so that's going to be 4 again. Negative 2 plus negative 5 will be negative 7. I'm just continuing along the top row. Now let's look at the bottom row. 4 plus 0 is 4. 0 plus negative 7 is negative 7. And negative 5 plus 2 is negative 3. And so I just add the corresponding elements. And so that's my answer. That is the matrix, the resultant matrix from adding A plus B. Okay, let's go to our next page. Okay, in our next page, we're given A and B again, but now we have A minus B. Well, you do the same thing, you just subtract them. So I have 1. My stylus is not wanting to work. 1, 3. Negative 2. And 4, 0, negative 5. And I'm going to subtract 3, 1, negative 5, and 0, negative 7, 2. And that's going to equal an answer matrix. Now, the dimensions of the answer matrix are the dimensions as each of the others because they have to be identical in order to add them. So here again, I'm going to say 1, but this time it's minus, so 1 minus 3 will be negative 2. Then I'm going to go on and do another. So I have 3 minus 1, and that's going to be positive 2. Negative 2 minus a negative 5. That minus a negative 5 is going to make that plus 5. So negative 2 plus 5 will be positive 3. 4 minus 0 is 4. 0 minus a negative 7 minus a negative makes that plus, so that's positive 7. And negative 5 minus 2 will be negative 3. So watch out for negatives when you're subtracting. You know, really, every time you need to watch out for negatives. So watch for your negatives. Be sure that you pay attention and not wath, since I can't spell. Watch. Okay, watch for your negatives. All right, the last thing we're going to learn today is multiplying by a scalar. This word here. A scalar is just a constant that you multiply by. It's just a number. It's a real number. And so what that means is that every element in the matrix, this matrix, is multiplied here by negative 2. Okay? So I'm going to multiply by negative 2 right there. Everything inside the matrix. So the first thing is to multiply. Negative 2 times 1, you get negative 2. Okay. Negative 2 times 3 will give you negative 6. Negative 2 times positive 3, again negative 6. And negative 2 times 4 is negative 8. Okay. So that part's pretty easy. The second problem, we've got to multiply two matrices by a scalar and then subtract them. Well, if you remember, if you just had 2 minus 3, you could change that equals something. You could change that to 2 plus a negative 3. And that would be the same thing. So this is the choice. This is what I do when instead of subtracting, it helps me to avoid making some negative mistakes. So I rewrite this, usually as an addition problem. So I'll say 2 times 1, 3, 9, 4, that matrix, plus negative 3 times negative 1, I don't know why, negative 1, 4, 0, 2. Okay? So I'm going to erase some of these examples here. Alright, so that's how I rewrite that when there's a minus right there. I write it as plus a negative. So then when I'm done, I add the two matrices. So now we're going to multiply by 2 each matrix. So I'm going to have 2, 6, 18, and 8. I've multiplied each element in here by 2. Plus, now I multiply each by negative 3 for my next matrix. So negative 3 times negative 1 is 3. Negative 3 times 4 is negative 12. Anything times 0 is 0. And negative 3 times 2 is negative 6. Alright, so then I have to add these together. And so that's what I'm going to do. 2 plus 3 is 5. 6 plus negative 12 is negative 6. 18 plus 0 is 18. And 18 plus negative 6 is positive 2. And then that will be my answer matrix. Okay. 4. This is a little different. Notice these parentheses here, here, and here. And the 4 is outside. That means that I have to add those matrices first and then multiply everything by 4. So watch for parentheses, watch for grouping symbols that may change what you have to do. So let's add them first. And y'all are pretty good about doing these things in your head. 3 plus 6 is 9. Again, you add corresponding elements. Negative 1 plus 8 is 7. 9 minus 1, or 9 plus negative 1, is 8. Negative 2 plus negative 2 is negative 4. 5 plus 9 is 14. And 4 plus 3 is 7. Now I have to multiply them by negative 4 for my final answer matrix. 9 times 4 is 36. 7 times 4 is 28. 8 times 4 is 32. 4 times negative 4 is negative 16. 14 times 4 is 56, I believe. I'm doing this in my head. 4 times 7 is 28. And so that will be your answer matrix there for 4-1. So that finishes 4-1, adding, subtracting what a matrix is, how to do dimensions, and multiplying by a scalar.